So thank you. Today I'm going to present the work that I have done for my industrial PhD for the last year. This work has been done in collaboration with Zeta Ingenieros and the supervision of Gonzalo Sanchez. Just as an introduction to urban wind energy, these are two wind power density maps at 100 meters and 200 meters from the ground. As you can see, there is at 100 meters, which is the typical height in which a windmill operates. There are a few regions in Western Europe where wind energy is feasible, but there are lots of regions where there is just either not a wind that is not strong enough or not constant enough in order to be viable. But then if you just go 100 meters higher, you get that in a lot more regions, we unlock the possibility of extracting energy from the wind. So there is a potential to get energy from a natural resource that is not being used. It can be used unless we use some kind of technology like urban wind energy. Typically, you have some kind of wind flying in a crosswind, in crosswind. And you unwind a tether that is connected to a generator, and then with that movement you generate energy. There are a number of examples, both from academia and from startups that have already proven the concept. These are just a few companies that are now in operation. But usually this data is linked to private companies and is not publicly available, so having experimental capabilities at university is very useful. So the objectives of my thesis were basically to improve the current experimental setup that we have here at UC3M, and then build a new ground station capable of producing energy. If you remember from the presentation of last year, basically we focused on the redesign of the old testbed. Just as a reminder, this work started in 2016 with the thesis of Ricardo Borovia, aimed at the characterization of kites, aerodynamic characterization. Then this testbed was built over the years, and it was described in a paper by Ivan Castro. And later we redesigned this machine and adding capabilities, and finally this year we managed to build a new ground station which I'm going to describe now. Also the group has grown bigger this year. We have joined forces with the electrical department of engineering here at UC3M, and with the help of also the team from Zeta Ingenieros, we have been able to do many more flight test campaigns than before. Some of which were very successful, some of which not so much. But we are happy to report that early this year we managed our first completely autonomous flight at Santa Maria de Alameda, our test facility in the north of Madrid. The data from this flight is being used to prepare a publication. So yeah, we were very happy about this result, and this is one of the objectives of my thesis. And then in parallel, we were focusing on the design of the new ground station. Basically, we wanted three objectives. First, we wanted it to be a proper demonstrator of the technology, so being able to produce around 15 kilowatts of power. We wanted it to be a universal platform, because usually these kind of ground stations are designed for one particular kind of kite. And we wanted it to be flexible, so if we wanted to continue with our delta kite, we could. If we wanted to transition to a rigid wing, like the one proposed by Jorge, we should be able to. And finally, we wanted it to be probably a research test bench, so fully sensorized and ready to gather data for scientific publications. So this is the CAD design that we came up with. Basically, it's designed to fit on the track that we have in the project. It should be able to withstand forces up to 4,000 newtons, combine all the tethers. And it is prepared to work either isolated or connected to the electrical grid, and has a battery system to smooth the output of the power. It can combine also the power from the wind and also solar panels or whatever we want to incorporate. From a functional point of view, basically, we determine the state of the kite fusing data from the kite itself, from the IMU barometer GPS system that is on board of the kite. Also, we have additional sensors like load cells are incorporated on the kite itself and a multi-hop PTO system that can be added. And all of that is fused with camera detection artificial vision system that is on the ground and line angle sensor. And together with the data from the anemometer, we get the state of the kite, and then we apply the actuation. All of that is coordinated by a central unit with the generation and storage subsystem. And we actually managed to build a system for the Urban Wind Energy Conference that we held here in Madrid, in Porta de Toledo, a few weeks ago. Was showcased in front of the whole Urban Wind Energy community. And yeah, just a few some achievements that we did this year. In terms of paper, I am preparing one that will hopefully be ready before summer. Then in terms of conferences, this year we had the Urban Wind Energy Conference, as I said, here in Madrid. And this year was very fruitful in dissemination activities. We had Semana de la Ciencia, as always, but we also have a lot of activities preparing for the conference. And we actually had national television, La Sexta and TCTV having us on the news. So I think it was interesting. And I think that's all. So if you have any questions, I'm happy to answer.